this is the car, right? So at the fixed point O, and it says that the displacement is given by this expression. What does displacement means? Displacement means the distance traveled relative to your starting point. So example, if this is my starting point O, and I say that my displacement is 15 meters, then I'm here. This means I'm 15 meters away from my starting point. So displacement is always where you are with respect to your starting point. But I can also say, oh, I'm at a displacement of minus 20 meters. Then if this is my starting point, then my left is the negative direction. So I'm over here. So displacement can be negative. But if I ask you, oh, what is the total distance I have traveled if I started moving from here to here and then get back to where I am now? So what is the total distance traveled then? 15 times 2 then plus the 20. I don't care about the negative sign. I want to know what is the total distance I've traveled. So you must differentiate what is displacement and total distance traveled. There's a bit of difference. Okay? So now if you look at the question, they say, can you tell me what's the velocity after 4 seconds? How to find velocity from displacement? Yes. So ds dt. So you go and differentiate your expression over there. 3t squared, 12t plus 9. So that's why I tell you, your concept of differentiation and integration is a very big part in your paper 2. You know how to do it well, a lot of chapters you can do it in one shot and you get a lot of marks. Okay, but they say after 4 seconds, so it's a good habit for you to sub in t as 4. So it will be this. Okay, what about acceleration? Yeah, so we differentiate your expression for t one more time. So this one differentiate one more time. 6t 12. Okay, but it's also after 4 seconds, so you should sub in t as 4. You get 12 meter per second square. So just take note of the units between velocity and acceleration. Velocity is meter per second, acceleration is meter per second square. Because it's the rate of change of velocity with respect to time. You divide by time again. Square. Velocity. Okay, then this one is done, right? Second one is done. Third one, they say find the time where the particle is momentarily at rest. What does it mean? Velocity is 0. So they want you to find the time where velocity is 0. You already know the expression for velocity. Just need to go and solve it. So it's a lot of language game. You just need to know what you are doing. Which one minus 12? No, then you factorize, right? You divide by 3 throughout. Then you factorize them. This one you can use calculator. They are not so particular. So your particle is actually momentarily at rest when t is 1 and t is 3. Yes. You differentiate this one more time. Yes, because it's dv dt. Yes. Okay? Very last part, the total distance move in the first 3 seconds of motion. Okay, so this is the only one that sometimes some of you might take some time to understand. But let's try to start off first. There's a few key points you need to take note of. You need to find displacement where t is 1, displacement where t is 3. Because at this point, it changed direction, remember? All this point, it is where your particle will change direction. So first, we go and find at the start, where is your particle? We cannot assume it always starts at O. We must check. So go and find your displacement when t is 0. So actually what they are trying to tell us is your particle is here. If let's say this is your O, your particle is 56 meters away. At the very beginning, it was here. This is where your particle is, or your car is. Okay, it started off at 56 meters away from your origin. Okay, then now we check at t equals to 1. We know the particle will change direction. So let's check the displacement first. Okay, so go and calculate your displacement. You will find out that it's actually 60 meters. So meaning your particle or your car moves until 60 meters. Okay, at this point. And then at this moment, it will change direction. So meaning when the ball or the car moved until this point, it was momentarily at rest, right? So it must change direction. So you make a little turn here. Okay, make a little turn here. This is where t is equals to 1. There is a change in direction. Okay, let's check at t equals to 3 where the particle is. Also 56, is it? So it goes back to here when t is equals to 3. By right, you know that if they want you to find 4 seconds, your particle will turn again and move, right? But they are not interested in that because questions say first 3 seconds only. Don't go and find beyond. So now I want to know what is the total distance traveled by that particle. It's just this 4 meter here and the 4 meter back. We don't care about the 56. We don't care about the 60. We only want to know what is the distance moved by the particle. So 4 meters over here and then another 4 meters backwards. So total distance traveled is just 4 meters times 2, which is 8 meters. Sorry? Yeah. So maybe the car basically just like reverse a bit. Yeah. Go forward a bit, then reverse. Accidentally step on the pedal. Okay, so usually the kinematics involves particle movements. But sometimes I don't know why over time they change it to car, they change it to other objects. But usually it's about particle. It's just like your Fast and Furious car step on the accelerator, then quickly reverse in the opposite direction. Like almost instantaneously, okay? But don't think of it like what you will do on the road. Because we are all very safe drivers, right? In future.
Do you drive?
Of course not.
I don't plan on driving.
Last time I went for driving practices, right? Then my I was like doing parallel parking. Then when I want to exit, right, I wanted to press brake, but I stepped on the accelerator. So I went out and my instructor was like, he pulled the brake. He was like so scared. So driving is really not for me. But I got license though. Just that I don't drive. I only collect the license. It will never expire. Just that my courage expired. Yes. Why did I? When? When I was JC year 1, 18, is it? 16, after 16, 17 plus. Yeah, when I passed my birthday. Yeah, 18, I think. Yeah. Yeah. Pass. Okay, next one. I have a particle K, another particle, a lot of particles. You know there's millions of particles or even more.
That's true, yeah.
Okay, where this E with, why this E don't want to go away? Okay. Okay, a particle moves in a straight line, so there is distance from a fixed point. Okay, listen carefully. When they use the word distance, but they say from a fixed point, they are also referring to displacement. Because they say it's distance from a fixed point, so they are referring to displacement. So they say the displacement is given by this. So take note of the language. And then they say, can you find the velocity and the speed of K after 5 seconds? So first thing first, let's go and find velocity. So velocity is ds dt. And then they want us to sub in t as 5. So 12t minus 3t square, sub in 5. Minus 15 meter per second. Okay, but they say they also want to know the speed. Speed is a scalar quantity. Whatever you see there, drop the negative sign. So the speed is just 15 meter per second. So remember, it's scalar. There is no negative sign. This is the vector quantity. There is a direction. Okay, so this is part 1. Okay, part 2, they say distance of K from O. So again, they are asking you for displacement when it is instantaneously at rest. Means what? So V equals to 0 first. Go and find the time. So this is my V. Let's go and try to solve that. So you get 2. One is where it's at the initial point. One is where it is at the 4th second. So they say, can you find the distance of K from O? Meaning they want to know what is the displacement at this point. So go and sub in T as 4. 4 seconds ma. Then you will get what? 32 meters. So your distance from the point O happens to be 32 meters away. So now we check the crucial timing you need to find is T equals to 0, which you know displacement is 0. You are starting at the origin. Okay, then displacement is 32 meters at 4 seconds. But they want you to find the first 5 seconds. So let me first draw the chart. Let's say this is your origin. At T equals to 0, you are here. Okay? And then at T equals to 4, you are 32 meters away from this point. That's what they are trying to tell you at T equals to 4. But because at this point, your particle is momentarily at rest, it's going to change in direction. So there's going to be one change in direction here, but you don't know where it ends, right? But they say first 5 seconds. So go and find when T is equals to 5, what is your displacement first? So displacement would be 6 5 square minus 5 cube. So you get 25 meters. Okay, so that means your particle turn and then stop where it is 25 meters away from O, not moving 25 meters. So this is where your particle stop at t equals to 5. So now they ask, what is the total distance traveled by that particle?
2 plus 7.
Yes. So because it moved here, right? This one clearly 32 meters. And then after the turn, it shifted here. So from 32 to 25, you go and take a subtraction. It's actually a 7 meters. So there's an additional 7 meters over here. So totally the particle traveled 39 meters. Okay, so as long as you can appreciate this, this is more or less the main point of the chapter already. Okay, although they like to use some keywords to scare you, but don't worry. Okay, I hope so far so good. No? This is part 2, this is part 3. Okay, do you necessarily always have to draw the graph? No need. They are not going to give you marks for that, but it will help you see your answer. Sorry, I enlarged for you to take. Let me just copy this question. Question 3 again, they give me displacement. Then they say, can you find the expression for velocity and acceleration and leave it in terms of t? So how to find v? V is just differentiate your s one time, right? So this one, rewrite it such that it's very easy to differentiate. Okay, the 6 will be gone. Bring down the minus 1, become positive. Subtract by 1. That's it. And then by right, you must multiply by the differentiation of the expression inside, which is just 1. So the v is just 9 over this thing square. Okay, we repeat one more time to find a. So it's dv dt. So if you differentiate this one more time, bring down the minus 2, becomes minus 18, subtract the power by 1, and then multiply by the differentiation. So the expression for A is this.
Why do you differentiate?
Because you must always multiply by the differentiation of this, right? Which happens to be 1 lah, but if you don't want to write, it's also fine. Okay, so that's your 2 expression. So your foundation for differentiation and integration is very important. It is a domino effect for many chapters. Because your chapter 14, maxima, minima, right? Then 15 is all your differentiation, quotient rule, product rule, okay, chain rule. And then your 16 is what? What is 16? Differentiation of trigo. Then 17 is the exponential, integration. Then finally now 18 is kinematics. Everything is linked. So you want to do well for paper 2.
Forget already.
Make sure, it's all linked. And then when you go your poly or your JC, right, the whole calculus gets haunt you again. They will start from differentiation of ln. They will do log, they will do search, then they do integration. Yeah, so it will come back to you if you go engineering. And if you do JC, it's default. It's your H2 math. Okay? Okay, next, they say, can you find the velocity of the body when it is 5 meters from O? What does this mean? Yes. Shh. So when they say 5 meters from O, they are saying displacement is 5. Go and sub in displacement to be 5. Yes.
Shouldn't this be negative?
Which one?
First one.
Oh, yeah. I think I missed that out.
Why?
Then this one become plus, oh. No, there was a negative in front in the expression here, right? So become positive. Sorry. Okay, so go and solve. Shh. Go and solve for T. Shift this over here. Bring the 5 over. So left 1. Okay, then cross multiply. It is 9, right? Not T, not A. Yeah, looks like A. So T is just when it is 6 seconds. So displacement is 5 meters from O, where time is at the 6 second. So they say, can you then find the velocity? So go and sub in T as 6. That's all. So it's really like a understanding question game. Then last part, they say, oh, acceleration is equals to this. Go and find the time that it happens. So just follow instruction. Don't overthink. Okay, so let's do a cross multiplication. Okay, if you take a cube root, it gives you 6. T is just 3 seconds. Cube root. Like a lot of llama in the class. Ken, getting better?
No.
Not yet.
I'm getting dumber.
What school? I'm going. Sport? I'm doing Jenga.
What sport are you?
Jenga.
I'm the Empire there, okay?
What sport do you look like?
Do I like
Yeah.
ball games?
No, what sport do you look like?
Do I look like?
What sport are you? Oh! Like, what is your sport?
I don't have a sport.
What's your favorite sport?
My favorite.
Wait.
Ball games lah, ball games.
If I join Jenga, can I cheat? Will you let me cheat?
No, I will catch you very strictly.
Yeah, even if he doesn't do anything, say.
There you go, cheat. Eagle, there Falcon all can.
Wait, I'm Falcon.
Oops, recorded.
Why's all my teachers all Falcon and it's not Eagle?
This is a good house.
Falcon not fair.
Okay, move on ah. No hop. Have, Hao Ming. Hao Ming, are you better? Are you feeling better? Yesterday you so no, not yesterday. The day before you so moody.
I think he went China to keep back.
What?
He went China and took his TYS.
Oh, your TYS ship back already or not?
Because money is very expensive.
Really?
What not fair?
This one go back.
Okay, question 4. I have a ball that is thrown into the air. Like that. Okay. And a distance s meter in t second is shown by this equation. Okay, if you look at it, it's like a parabola equation, right? So you know it's going to be like a maximum curve. You look at this one. This is your maximum curve quadratic, right? So find the velocity of the stone. Your smiling curve and your frowning curve lah.
Oh no, like what
The
is
quadratic
parabola?
is a shape.
Oh,
Yeah.
it's a shape.
Okay, so find the velocity of you. They are so confused. One time is ball, one time is stone. Okay, but never mind. You know it's something circular. Okay, so first they say, can you find the velocity when time is 1.5? So go and find ds dt first. So let's differentiate this. You get 20 minus 10t. And then go and sub in t equals to 1.5 to find the velocity.
5.
Meter per second. Okay, then the other one, they say go and find the velocity when time is 3.5. So you get a minus 15 meter per second. So they ask you, what is the meaning of a negative velocity? Yes, your particle is moving downward. Next, they say find the time when the particle is 15 meters above the ground. So meaning you want this to be 15, your displacement to be 15, and then we will try to solve it. So it is where time is 1 second or when time is 3 seconds. Okay, why will there be 2 answers?
Because it's one that is moving because the wall bounce.
Nope. Why is there 2 answers?
One going up, one going down.
Yes, because there's a change in direction. This is where the particle is, okay, moving upward by 15 meters. Okay, the other point is where you are 15 meters away from the ground, downward. So due to the change in the direction, there is an upward movement 15 meters and there's a downward movement 15 meters. So that's why there's 2 answers.
This Leon. This
Can you
Leon.
ask the people to like
I can't.
Like, can you shout again?
Can't. I don't have this power.
Who has the
I wished. Principal. Principal can.
minister?
Oh, of course. Okay, let's look at 5.
No, not done yet.
How come you always talking then not done yet? Huh?
I'm not talking. I never talk.
Like talk to me. I thought you done already, that's why you can casually talk.
Huh? I never talk.
Done. Focus. You're too casual already. You all can write and talk at the same time and
Yeah, we are asking each other general knowledge questions.
totally.
Oh, you? I don't know what you're doing.
Like would you rather
Yeah.
Is it rather do AMF or do AMF?
A and A? Okay. This one. Body moves in a straight line. Distance from fixed point is this. find the values of P and of Q when time is 4 seconds, velocity is 0, and acceleration is 12. So they are giving you many information in one shot. So what you can do is, you can do a few things. This is displacement, find velocity, find acceleration. So the three expression, go and differentiate it, and then based on the info they tell you T is 4, V is 0, acceleration is 12. Go and plug in and solve for unknown. So the first one you can solve is, of course, sub in A as 12 and T as 4. So Q is half. Okay, once you are done with that, then of course you can go and sub in your V as 0, T as 4, and Q as half. So the moment you do that, (16) you half it is 8, so it's 24. P is minus 24. Okay. Then lastly, they say, oh, then we are done already, what?
No, we need to find the one.
Okay, so find also the velocity and acceleration when time is 1. So this one and this one, they want you to find one more time. But now is where at time equals to 1. So velocity is this. (1.5). So minus 22.5. Then the other one is acceleration. Okay, so it is all about following the instructions carefully. Okay, most of it is similar, but just that I want to do the integration type of question. 6 part 3 I need to show. Done? Okay, need to be a bit faster, ah.
I can't. It's so complicated.
Why?
I'm still digesting.
Wow. If you can, I want to. Baby. I can't imagine.
How me you doing or not? Are you doing the questions? That's not the point. Okay, let's look at 6. There are some keywords that I haven't explored with you yet. but it's not totally new to you. Okay, this one. Again, same thing is displacement, but they say initial displacement. What does it mean? When you see initial, t is 0. So this one you all need to know. So when t is 0, s is minus 12 meter. So meaning your particle started off moving at this point. Where t is 0, your particle is 12 meters away on the left. S means for? No, displacement. S is displacement. Okay? Next it says find the velocity of P when it passes through this point. So what do you think the question is saying? S equals to 0, meaning when you are at your origin point, S is equals to 0 here. So they don't tell you directly, but you must understand what the question is saying. So when S is equals to 0, go and solve for the T first. So it is when time is 2 or negative 2. This one is nonsense, so you reject. Time cannot be negative unless you can turn back time or got time machine. Okay, but they want the velocity. So you need to go and differentiate your expression one time first to get 6t. Then you sub in time as 2. Okay? So it's quite sequential. Just make sure you try to understand what they want you to sub in. They don't tell you directly. Kinematics is like girls. They don't tell you directly. You need to read between the lines. Okay? But we are always very clear what we are trying to tell you. You must catch it. Yeah. Look out for keywords. That's the thing.
What do you guys mean? Can you tell me?
Okay? Show that P never comes to rest. What? Yes. Because they say I want it to pass by my origin. When it goes here, I'm 0 distance away from my origin. So it is indirectly telling you displacement is 0.
So loud.
Yeah. Okay. They want me to show that P will never come to rest. What does coming to rest means? Yes, so they are trying to tell me, no, they are trying to tell you to show them that V can never be 0. Okay, so first thing first, as it passes through here, time is already going to be bigger than 0, right? Your time started already. It cannot go back to anything lesser than 0. So what we know is as t is greater than 0, v being 6t will be greater than 0 as well. Because it's like multiplied by 6 on both sides, right? So v will always be greater than 0. So since v can never, this is what you want to show. So since v can never be 0, it can never come to rest. It will continue to move after time starts. So this particle will never stop. Just like your format. Wait, got one part 4. Can you have some? Okay, wait. Since the particle will never come to rest, it will never be 0, there's no change in direction. What does this tell you?
Yeah.
How can you find the total distance?
Just plus all. Add them up together.
Actually, all you need to do is to go and find your displacement when time is 3. Right? So because there's no in between that it turn here or turn there, right? It just keep going to the end. So what is the displacement at time equals to 3? Go and find that first. Then you realize it's 15 meters. So at time equals to 3 is 15 meters away. So it comes all the way to here. So how can you find the average speed? What is the total distance traveled by the particle? 27, not 15, because it moved from here to here, right? In the first 3 seconds. So there's a 12 meter here, there's a 15 meters here. So total distance traveled was 27, and then divide by the 3 seconds. So it's just 9 meters per second. So as long as you understand the story, the concept is very simple. As long as you understand your SVA, the concept is very simple. So today you go back home and you will do 7 to 15. Okay, even if they ask you to do the opposite, it's just integration. Remember, there must be a plus C that you need to solve. Okay, you go back and try. Don't spin Don't let the spinner decide your fate. Do all.
No.
Do your best, 7 to 15. Today no CCA, right? No coursework,
I
right?
have NCT today.
You still dare to stay. You got farewell already, you still want to go back. Still got the cheek to go back. And today is Wednesday, where got CCA? You what? You what the whole day?
So I have to eat and sleep.
Yeah, we have a lot of work.
You all have O levels.
This is very important.
No. No.
Why you deny
So
us?
you never understand.
Okay, you must remember, that while you are resting, there must be people that are working.
Okay, that makes sense.
While you give up, there must be people that can continue moving.
If you are working, there must be people that are resting.
But do you want to be the one who is resting
Yeah.
at your age?
Just
Okay? The problem that you give up solving, there must be other people who's trying to solve it. So think, okay, next is your 10-year series. You all must know, by the time maybe next week, somewhere in the middle, if we manage to finish syllabus, we will start going through all this. So I need you all to get all this done, the first 5 years. I only received Leon's and Gracie's one, but the rest of you, if you want to hold on to it, it's okay. Just that by the time when I say I want to go through, you take it out, it's done already. You don't sit there and pretend that it's done.
you never do email for me.
Start.
But I'm not done. I'm not sure.
Start.
Can do it in the button.
But you cannot do or haven't finished. Or you want to finish first and continue?
Everyone is 89%.
You do.
Everyone is 89%.
If you look at the expression here, this one equate to 0. Okay, you go and try to, I think you can use your calculator, but let me just try to simplify this. What should it be? Minus 8 plus 2, So at t equals to 8 seconds, it will turn 1 time. This one you will reject because it's nonsense. There's no negative time. So you are only interested in finding t equals to 0, t equals to 8, and t equals to 12. This is where it starts, where it ends, and where it turns. Then you can find the total distance. So do we have the expression for displacement, or we don't have? Oh, in fact, we miss out part 3, right? Part 3, this one, sorry. Okay, displacement, how to find? Integrate velocity. So let's go and integrate this thing first. So add 1 to the power, divide by new power. Add 1 to the power, divide by new power, plus C. Okay, so same thing at the start. They already tell you it passes through the origin with velocity 8, and it is when t is 0. You pass through origin means at that point you will add the origin. So you sub in S as 0, T as 0. Actually, C happens to be 0 in this case. So this is your expression. For displacement. So the displacement when velocity is at rest is they want you to sub in t as 8, because you already solved that it is at rest. This one means at rest, right? When t is equals to 8. So go and find the displacement here. Sub in 8. What's the answer? Do I have it here? Because I want to find, this question say find the displacement of the particle when it is at rest. And it happens at 8 seconds. So what's the value? Oh, I got 74 2/3 meters. So this is 74 2/3 meters. This is 0. Okay, the last thing you need to find for part 4 is the whole of part 3. Okay, for part 4 is the displacement when time is at 12 seconds, because question wants you to find first 12 seconds. So let's sub in again. You will get 24 meters. Okay, so we check out. Let's draw the particle movement. My particle started off at the origin here. Then at 8 seconds, it traveled 74 and 2/3 meters. So it was here at 8 seconds. But because at this point it was also momentarily at rest, there is a change in direction. Okay? Then at the final 12 seconds, it is back to the 24 meters mark. So it went back to somewhere here. It was 24 meters away from O. So remember, it's displacement. So what is the distance that the particle has traveled in the 12 seconds? This one. And then you must add to this, right? Okay, so total distance. Yes, you can leave in fraction. So total distance from the two part. And then flow is this one minus 24. Okay, so you should be able to find that the total distance traveled by the particle was this. So average speed is this divided by 12 seconds. Okay, so this is the most complicated that they can ask you already. Integrate, find back the original expression, maximum velocity at rest, instantaneously at rest, all this. They can have many parts and then they test you on it. Yeah, so kinematics, as long as you understand what the question is talking about, they are there to give you marks. So read the question carefully, do your integration properly. This is 9. Okay, so this whole thing is part 4. the plain geometry notes first. 3, 4, 5, 6. Because I have 2 videos that were recorded last time, that I can actually get you to go and watch the video for all the solutions. You don't have? You give his copy to your new friend. So sad. Okay? Can I hope you find kinematics friendly. Plain geometry is like congruency and similarity, all proving level 3.0. Okay, so if you can do proofs, then plain geometry is okay. No, may not have time to start, but I give you all first. Because I'm going to send you all 2 videos, so this long weekend, if you all want to watch it and get started first, go ahead. Because it's all just proving. Yes. Can. When? Can. When? Next Wednesday after school. Yours after school better, right? Morning too early. Okay, Wednesday, next Wednesday. Okay, next one. Who? Okay, new student must wait. Okay, new student wait first. Andrew. Where do you all learn all these things? I'm disturbed. I must record this. If not, nobody will believe what I say when I go back. Now even my girls are like this one is real, like Russia. Yeah. Okay. Yeah, it's all recorded. All the Andrew talk. 3 years later, if I share this video with another class, when they self-learn kinematics, they'll be like, what is this class doing?
No, they're gonna keep up with the storyline and suddenly where the Andrew come from. But it's nice.
No, they will ask me, Miss Huang, did Andrew get through O levels?
Yeah.
Cheaper.
I asked Andrew whether you want to take theory A math. He said you want to take A math.
Sure.
Where are you running? That's why Andrew is better than you. No, Andrew's not real, okay? Andrew's real, right? So imaginary friend.
Done. Oops.
Wait.
No. After school, 1-to-1. Together with Rochelle. Can I?
Yeah.
Faster. Okay, next one. Okay, this one I'm not 11. I just want to do this part. When they say show that it will never return to origin, they want you to show that it will never, S can never be equals to 0. So if you look at the expression given over there, is there a chance that it will become 0?
No.
Return to origin. It's moving in a straight line.
Where are my notes, man? Why do I see 2 layers? Wait, never mind. One
See?
layer.
Wait. I am trying never return to. Okay, if something keeps going in one direction, for example, whether or not this particle was on the left or on the right. Okay, imagine if I sub in t as 0, I started off with let me see 15 minus 5, 0. Okay, I was here, right? So as t becomes 1, I get displacement 2. So that means particle is moving in this direction. When will the particle never return back here? When will it never return back? When your V has no chance to ever turn direction, right? So if you can show me that V is never zero, then you can conclude that the particle will just keep moving towards infinity but never turn back and never got a chance to pass back the origin. So my objective is to show that. So how to find V first? So we differentiate. So let's write the S in a very friendly manner so that it's easy to differentiate. Okay. Thank you for talking about the S's. Okay, so differentiate the expression inside. Remember the times 2. So you should end off with this. Okay, we learned at the very beginning of A math that if we square an expression, it is always positive. Okay, so for all real values of t, your 2t plus 3 square is always greater or equals to, in this case can never be 0, if not it will be, the fraction will be nonsense. So it is always greater than 0. So if you use a positive number to divide by a positive, it will still be positive. So I've just proven that V must always be a positive number and it cannot be equals to 0. T is a comma.
Mine looks like 5.
That's a comma. Okay, I write too near. So sometimes it's good to have a bit of distance from your friend. If not, there will be misunderstanding. Okay, so therefore, particle will never return to origin. So this is the only part that I think you will need more help with. Let's look at what about 13 because got sign. Then you're scared. Why let 13? What's wrong with 13? If they need you to differentiate, you differentiate. Okay, we look at 13. 13 say a particle starts from a fixed point, move in a straight line. Velocity is given as the expression there. Find the distance traveled. So starts from a fixed point means displacement is 0 when time is 0. Because you start off here. Okay? So now question say, can you find the distance traveled by the particle when t is given by this time? So what do you think you need to do? You need to find S, right? So how to find S? Integrate sign. You all still remember how to integrate sign?
Equals cosine.
Just cosine? Negative cosine. And then you divide by the differentiation. 2. Then this one is just t square over 2 and then with a plus c. So this is your expression for displacement. Sub in 0, 0, 0. Cosine 0 is not 0. What is cosine 0? 1. So this is a minus half. So C is actually half. So your displacement expression is this. Okay? So this is your displacement expression. Then you need to sub in T as pi over 2. So let's do that. Why? Scaring the person. Okay, so this one is cosine pi. Pi is 180 degree. It gives you a minus 1. right? If not, you just key into calculator, make sure it's in radian mode. Because the 2 cancel out with the pi over 2. You're supposed to sub in t as pi over 2, right? Okay, so when you put that in, pi over 2 or pi, sorry. Okay, so you will get half here. This is pi square over 4 divided by 2 pi 8. So you end off getting your answer as this. Okay, meters. Okay, how come you know that my displacement, once I sub in this, straight away is the answer? How do I know whether it doesn't turn back? Because if you look at this, there is not really a chance for it to become 0 again. Okay, because V cannot be 0 for a sine graph with a plus T over there. It will always be greater than 0 or strictly less than 0. There's no chance that it will become 0. So there's no turning back in this case. Yes. Sorry? Where is the... because when you cosine this value, it becomes minus 1. Cosine 2 pi over 2 is cosine pi. Cosine pi is minus 1. So when this is minus 1, then you end up with a half. Okay? So last, they say find acceleration. You go and differentiate your velocity. So differentiating sign is cosine. Okay, same instant. So meaning sub in t as the same value. So it's just minus half plus 1. So it's just half. Half meter per second square. Did I get wrong? Minus 1. Minus half. But the answer there, right? Minus 1. Did I do anything wrongly? Differentiate sign is cosine. Oh, but you multiply, not divide. My bad. Multiply by the differentiation, right? Okay, so here it's a negative 2. So that's why you get a negative 1. Okay? So it's differentiating. You differentiate sign, you get cosine, you multiply by the differentiation, not divide.
It's not even my turn.
It's just an object or a particle. So they like to write object, particle, car, or sometimes they say a body. Okay, like Andrew. Yeah, Andrew is somebody. Or nobody. Okay, I'm so sorry, Andrew. Okay, after leaving fixed point O, so same thing. It is actually S equals to 0, T equals to 0, because you only start the timer after it passes through the fixed point O. So they say, can you find the acceleration? So acceleration, what do you do to velocity? Differentiate. So remember, differentiating exponential is very easy. Just multiply by its differentiation, which is minus 1/3. Then the rest keep. No change. No minus, no plus. So sub in T as 3. So this is minus 2. Yeah, so you end up having this. Okay, go and press calculator, 2 decimal place. They wrote the answer as this, meter per second squared.
So can you ask them to know to leave it?
They say, if they don't, it's 3SF. If they say in terms of E, then you leave it as E. Depends on marker sometimes. But actually it's considered exact. I would think so lah. But if you are unsure, leave it as 3SF. Yeah. But certs we can confirm. Okay, part 2. The distance traveled in the 3rd second of motion. Okay, this one important From 0 to 1, we call it the 1st second. The 1st second. From 1 to 2, it's the 2nd second. Okay? When they say the 3rd second is between the movement from time equals to 2 to time equals to 3. So don't belittle this one because sometimes they say go and find the 50th second. Then you must know where it belongs to. So if it's the 50th second, it's between time equals to 49 to 50. That is the timing that it happens. So they want you to find the 3rd second of motion is between here and here. So you are interested in finding this motion. So you need to go and find the displacement at t equals to 2 and the displacement at t equals to 3. So this one, you can find displacement by integrating this first. So integrating exponential is the same thing. Constant, leave it out. Keep the original expression but divide by the differentiation of this. And then do a plus C. So you sub in S as 0, sub in T as 0. You end off with 18. So displacement is minus 18. Okay, so you go and find what is time equals to 2 and what is time equals to 3. Yeah, t equals to 2 and 3. Go and find these two. Because they say in the 3rd second, not t equals to 3, it's between the 2nd second and the 3rd second. So go and calculate these two. What do you get? Okay. Okay.
All I see is stupid ass in my eyes. Like my eyes.
I'm tired.
I'm looking at you.
Okay, what's the two answer? Okay, anyway, if you take the difference between the two, you should subtract one from the other. And then that will be the distance traveled. What's the answer? Which one is 2.62? Oh, this one. Okay, so you just use either one of them to subtract the other one, then you can get that. Alternatively, you can integrate your V, right, to get displacement, and then you sub in 2 and 3 directly. So if they ask for the 3rd second, your lower limit is 2, your upper limit is 3, then straight away you get this one expression, sub in 3, and then sub in 2 and take the difference. It's the same thing. So this is the similar method, but in one step lah. But this one you can do in 2 different steps. This one you don't need to go and find plus C. This method, no need to find plus C. Because you know what values of T to sub in. So plus C is not essential here. But if you are doing by this method, you need to go and find the constant C first. Okay, so this one no need to find C. Okay, so just take note this question when they say the third second. When they say the third second, it does not equals to T equals to 3. It means it's between 2 and 3. Okay, the third second.
So weird. Why are they doing something like this?
Okay. Is there one last one? 15? So long Yeah?
So like if you ask second,
Between 1 and 2, yes. So if they ask for the 50th second, it's between 49 and 50. You will see in the 10-year series that they asked this question before. Yeah, why my system hang?
Please hang longer.
Maybe who? Andrew, huh?
Yeah, and
Is playing with my screen. So scary, right? What
Yeah,
you
just like
talk
that.
nonsense.
you put the papers right there.
Okay, great. Okay, two particles leave point O at the same time, moves in the same direction along the same line. So P starts with a velocity of 7 and moves with a constant acceleration of this. Q starts from rest. So that means here at T equals to 0 and S equals to 0, V was 8 and A is 1. That's what they are trying to tell you for particle P. But for particle Q, it starts from rest and moves with a velocity, acceleration of A. So meaning when T is equals to 0 and displacement is 0, velocity is at rest and acceleration is A. It is just A. Okay, so that's all they have communicated to you. So it tells you particularly that for Q, it is the acceleration is 1/5 2 plus 3t. Okay, so find an expression for the velocity of each particle in terms of t. So first thing first, this I can integrate by expanding it out first. So this is 2/5 plus 3/5 t. So if I find velocity, I integrate this. What happened? So for particle Q, if you simplify it, you get 3/10 t square.
Okay, I give up.
Okay, but velocity was 7 when t is 0.
So much easier to read or type.
So C in this case is 7. So this is your first expression. This is velocity of Q. Don't touch.
No, Andrew asked me.
Is that what you do at home?
Yeah. Andrew coming best friend. Why is this? Because I sit next to the screen.
Just a left triangle.
But I don't love that. It's a triangle. It's a straight line.
Okay, but for P, right, it's a bit different because P started out with velocity 7. Okay, that's what they tell you. And the acceleration was 1. Okay, so if we were to look at it, if I were to integrate your
Oh my days.
okay, if I were to integrate my acceleration, which was at 1, okay, it happens to give me t plus c equals to v. Okay, so if I were to sub in this as 7, was it 7? Oh, this was at rest, my bad. This was at rest, right? Q was at rest. Yeah, Q was at rest, so C is actually 0, sorry. Okay, Andrew, sorry. So C is 7, so V is T plus 7. So this is for P. These are the two velocity that you will get for P and for Q. Okay, if you want to find displacement, oh no, distance traveled at what time? Just integrate, right? Yeah. Okay, if you want to find distance traveled, then of course you need to find the displacement by integrating this. So it's t squared over 2 plus 7t plus c. Aiyo, disappeared.